Okay, we now have seen how we can apply operations to vectors, and these operations lead to some expressions which could be considered as functions of x and y of the two vectors. But usually in elementary mathematics we have the functions of only one variable, only one, let's say, vector in MATLAB. Let's choose x, create a new script and call it vector functions, and then type CLC clear, and then type new x. Let's say we want our function to change from 0 to 10, and we'll consider this as an argument of the function, and this argument has values from 0 to 10 ranging in 1, so it's like the difference between different values is equal to 1. And now we'll say that the function, our function, is a parabola, a quadratic function, simplest quadratic function. This expression is almost the same as we've seen before here, but instead of vector y, we have now just a number 2. And it works in the same way as with two vectors, but this time this operation is applied to each element of this vector because we have the dot here. Let's check that. Yeah, we see that if we open x in the variable browser, open y in the variable browser, and just move the variable browser for y, we can see both x and y variables. And we see that 0 to the second power gives us 0, 1 to the second power gives us 1, 2 to the second power gives us 4, 3 to the second power gives us 9, etc. And 10 to the second power gives us 100. So, in other words, again, we have application of this operation element-wise, but this time for only one vector. Now let's plot this function. So this is considered as a function, this is considered as an argument. So we plot a function y against an argument x, or we plot the vector y against the vector x. And now we see that MATLAB produced figure, and this figure shows us a parabola, one part of the parabola. So if we want to plot another figure nearby, we can create another vector. Let's say this is y and this will be z. And let's put z equal to sine of x. That will be another function of x. And now we can type x and z. So this plot will produce first curve where y is function and x is an argument, and the second curve where z is a function and x is an argument. It will produce those two curves in the same plot. Let's see. Yes, we see that there is a parabola and there's a sine. But sine is it has very small magnitude, very small value compared to parabola. So let's multiply this sine by 10 so that it would be visible. Yeah, we see now that the figure was already saved. That's why it is not produced automatically. We have to click down here to see the figure. Okay, now we see that we can actually see the sine, but we also see that it is pretty crappy because we have too few points to make a curve look nice. In order to make more points, we can just go back to the argument and type in a step here. Let's say it's 0.1 step. And now we see that the sine became much better looking. It's now much better looking and we are satisfied. But there's another way to produce the discretization of argument, meaning that there's another way we can produce the same points. And if we remember correctly, then we should say that this method is called linspace. First, we give the initial point, then we give the final point, and then we give the number of points which should lie in the vector, which should be inside the vector. Let's say it's 100, and let's call this x1 and put x1 here, and let's call this x2 and put x2 here, and let's put x1 here and x2 here. So now we can control the step for two different curves separately, and this step we will control by just changing this value. Let's say we want to make it 1, because parabola does not need many points to produce a nice figure. But here we will have 100 points because we need more points to produce nice looking sign. So here there are 10 values, and here there will be 100 values which lie between 0 and 10. So let's take a look. Yeah, and it still looks nice. Okay, we close it, we run it again, and then it's produced automatically. If we do not close it, let's say, but we just click back on MATLAB window, back to editor, and then run it again, we cannot see the figure. Why cannot we see it? Because it is not produced again, so it's not produced automatically. It just overwrites the old figure with a new plot every time. And then we have to access figure like this by clicking here and then pressing on figure. But there's a better way to avoid it. We can close the figure window automatically every time if we type in close. And if we have more than one window, then we can use close all to close all graphical windows. So if we now run again, we will have this window, and even if we press again on editor and then press run again, now we have figure produced automatically every time, because we every time close it in the beginning of the script.